If you've ever scrolled past a photo of water that looks like this, your brain probably instantly flagged it as fake. It looks heavily edited. It looks like someone spilled 1,000,000 gallons of blue food coloring into a valley. But I promise you, if you stand right on the shoreline, the water really is that incredibly blue. There's no digital trickery. There are no chemicals. What you are actually looking at is one of the most violent geological machines on the planet. A machine that alters how light itself behaves. Welcome back to World Tour with D. Today we are tearing apart the extreme geography and physics behind Earth's brightest lakes. We are going to look at the invisible forces that build them, why their color physically changes depending on the hour of the day, and why, if you don't visit them soon, this impossible blue might disappear forever. Part 1. The Glacial Engine, Violent Geology. To understand the water, you have to ignore the lake and look up at the ice. Glacial lakes don't exist without glaciers, but we tend to think of glaciers as just big blocks of frozen water sitting on a mountain. They aren't. Glaciers are rivers of ice, and they are unimaginably heavy. As gravity pulls millions of tons of ice down a valley, the glacier doesn't just slide smoothly. It acts like a colossal bulldozer. Through a process called plucking, the bottom of the glacier literally freezes onto boulders and bedrock, ripping chunks of stone out of the mountain as it moves forward. So now, the underside of this moving ice river is embedded with rocks. It has teeth. As it continues to slide, those embedded rocks grind against the mountain below in a process called abrasion. It's basically nature using a 1-billion-ton sheet of sandpaper. This friction is so intense that it pulverizes the bedrock into a microscopic dust. Geologists call this glacier flour or rock flour, and this dust is the secret ingredient. Normally, if dirt washes into a lake, it eventually sinks to the bottom. But rock flour is incredibly fine, often less than 2 micrometers thick. Because it's so infinitely small and light, it defies gravity. When the glacier melts in the summer, water washes this rock dust down into the valley, and the particles just hang there, suspended in the water column permanently. Part 2. The Physics of Impossible Blue. Okay, so the lake is full of invisible rock dust. Why does that make it look like blue Gatorade? For that, we have to talk about the physics of light. Think about the ocean. The ocean is blue because water naturally absorbs long light waves, the reds, the oranges, and the yellows. The blue light waves are shorter, so they bounce back to our eyes, but ocean water is mostly clear. Glacial lakes are entirely different because of particle scattering. When sunlight hits a glacial lake, it doesn't just pass through the water. It physically crashes into millions of microscopic pieces of quartz and feldspar suspended near the surface. These particles act like tiny mirrors. They intercept the sunlight and instantly reflect the blue and green spectrum back up into the air before the water can absorb it. You aren't just seeing blue water. You are seeing sunlight bouncing off a cloud of pulverized mountain. Part 3. Case Study, Moraine Lake and Lake Louise. To see this engine working in absolute perfection, you have to look at the Canadian Rockies, specifically Banff National Park. Long before they were the most photographed lakes on Instagram, these waters were known to the Stoney Nakoda First Nations. In 1882, a Stoney guide led a railway worker named Tom Wilson to a place they called the Lake of the Little Fishes. Today we know it as Lake Louise. It's fed by the towering Victoria Glacier. But just a few miles away is Moraine Lake, fed by the Winkchimna Glacier, and it takes the optical illusion to an entirely different level. Timing is everything with these landscapes. The light doesn't just matter, the heat matters. If you visit in May, the water actually looks pretty dark and ordinary. The glacier hasn't melted enough to pump the rock flour into the basin. But by late June, July, and August, the glacial melt is in overdrive. The rock flour concentration peaks. This is why planning a trip here requires some strategy. Being on the rock pile at Moraine Lake or Sunrise isn't just about beating the crowds. though that's a massive bonus. Securing an early morning transit pass means you get to actually watch the lake turn on. In the pre-dawn shadows, the lake is dark, but the exact second the sun crests the 10 peaks and hits that suspended rock flower, the water visibly shifts color in real time. It's like someone flipping a light switch. Part 4, the climate clock. But here is the harsh reality about the geography of these lakes. They are on a ticking clock. This vibrant color relies entirely on a delicate, violent balance. You need a massive active glacier constantly crushing rock and feeding it to the lake. As global temperatures rise, glaciers in the Rockies and around the world are in retreat. They are shrinking faster than they are accumulating snow. Eventually, the Victoria and Winkchimna glaciers will melt away entirely. When the ice is gone, the grinding stops. The rock flour supply will cut off. Slowly over the years, the suspended dust will finally settle into the mud at the bottom, and these brilliant neon lakes will become perfectly clear, ordinary alpine water. They are a temporary geographical marvel. We just happen to be alive at the exact right moment on Earth's history to see them. Part 5, Rapid Fire Fun Facts. Alright, before we pack our bags, it's time for the rapid fire facts. Let's go. Fact number 1, the forbidden water. Because this water is essentially pure melt water mixed with pulverized rock, it has a weirdly soft, velvety texture. But do not drink it. Filtering out microscopic rock dust is nearly impossible without heavy-duty gear, and drinking raw mineral dust acts as an incredibly potent natural laxative. Fact number 2, the $20 view. The view of Moraine Lake from the rock pile is so geographically perfect that from 1969 to 1979, the Canadian government put it on the back of the $20 bill. To this day, the spot is still nicknamed the $20 view. Fact number 3, heavy metal ice. When a chunk of the glacier actually breaks off into the lake, it doesn't look white like an ice cube. It looks like a glowing blue crystal. That's because thousands of years of extreme pressure have squeezed every single air bubble out of the ice, making it incredibly dense and altering how it absorbs light. Part 6, the global cousins. Moraine and Louise get a lot of the glory, but the Earth pulls off this optical trick in a few other spectacular places. If you want to add this phenomenon to your map, look here, Lake Tekapo, New Zealand. Sitting in the shadow of the Southern Alps, this lake gets its rock flour from the Godley River. But what makes it a must-visit is the contrast. During the summer, the shoreline explodes with millions of invasive but beautifully vibrant purple and pink Russell lupine flowers. Next is Lago Argentino, Patagonia. This lake is fed by the Perito Moreno Glacier, one of the few glaciers on Earth that is actually still advancing. The sheer violence and volume of ice crushing rock here makes the water a cloudy, milky ice blue that looks almost completely opaque. Nature's chemistry and geology will always beat a digital filter. Every time you look at a photo of a glacier lake, remember that you aren't just looking at water. You're looking at the physical dust of a mountain that has been crushed by millions of tons of moving ice, perfectly catching the sun. I want to hear from you guys. If you had to choose between seeing the vibrant summer turquoise of Lake Louise or visiting in the dead of winter to see the frozen, trapped methane ice bubbles under the surface, which trip are you taking? Let me know in the comments below. Make sure to hit the like button and subscribe for more deep dives into the wild history, geography, and geology of our planet. I'm Dee, and I'll see you on the next stop of the world tour.